All right, so here we go. We got these two equations right here. Let's I'm gonna cover the second one just so we're not distracted by it, okay? So here I got two equations, and we want to see if this ordered pair would make both of them true. If it makes any one of them false, automatically it is not a solution to this system. And remember, a system of equations is just when you got two or more equations that really we would want to be equal to each other. So let's write this out over here. Now we got an x minus y equals 3. And in this ordered pair, I got an x value that's 4, a y value that's 1. So let's replace the x and y with 4 and 1. So 4 minus 1, would this be true? Yeah, because 4 minus 1 is 3. 3 does equal 3, that's true. So the first equation gives me a true statement when I replace x and y with 4 and 1. How about the second equation? Well, that's 2x minus 3y equals 5. So let's replace those two values, x and y, with the numbers that they gave us in the ordered pair, where x is 4 and then the y is 1. And we'll check this one also for truthfulness. 2 times 4 is 8. 3 times 1 is 3. Does this equal 5? Yep. 5 does equal 5, at least for now. And that's true. So I got a true statement on both, which means that yes, for 1, the ordered pair is the, I guess, the solution. Now this means, again, if you were to graph these two equations, let's see, negative x plus, so on a graph like this one, we'll make this one purple. It'd look, I guess, something like this right here. And then we'll do this one in orange. Just choosing those colors randomly. 2/3, and then I guess it'd be, I don't know, something like this. Yeah, I'll try to make that a little bit better. Something like this, okay? So 4-1, I should do that better. 4-1 would be, I guess, somewhere in this direction right here. This right here, well, this activity that we just did, I guess if you want to call it an activity, this is what you would do after you found that the two lines intersect, okay? Because it would say, hey, look at this point right here at 4 and 1, right? And then after you saw that this is where they intersect, then you would go back to the two equations. And as far as I know, we don't require this on any test, quiz, or assignment. But should you do it? Definitely on tests, which unfortunately I did not see a lot of on the last exam. If you're doing it on a calculator, that's fine. Just hopefully you're doing it, right? Although sometimes the answers are wrong, so clearly you're not checking. But yeah, you'd get your answer here, and then you'd go in here and check, okay? But I highly encourage doing this step because, yeah, that's why it's on the homework. That's why we're emphasizing it right now. Here's that second one right here. So new values, okay? And we got new x and y values too. Let's check these equations. So 3x minus y equals negative 12. All right? And it says that x in the ordered pair there is negative 3. So I replace x with negative 3. I replace the y value with 3, and then I check for truthfulness. All right, well, 3 times negative 3 is negative 9, minus 3. Will this equal negative 12? It looks like it. Negative 9 minus 3 is negative 12. Yep, so that's going to be true. Now, hopefully, we have more persistence than to just be like, hey, that was super fun. And it was. It was like, hey, that made me feel good inside that it was true. But we got to check the second one, right? X minus y equals 0. Now, if by chance we found that this one was false, we're done, and we say that's not the solution, okay? Automatic. It doesn't matter if it's on this line or not. But I do x minus y, and I replace the x with negative 3, it looks like, and then the y value with 3. And then here we go, check for truthfulness. If you do this in your head, it's a common error to say negative 3 minus 3 is 0. It's not 0. It's negative 6. So be careful. And if you need to use a calculator for that, please don't feel ashamed to do it. No, I highly encourage calculators. Now, this is false, though, for now. So negative 6 equals 0 is false. So automatically, even though this one was true, that means that negative 3 is an ordered pair on the line for this equation. But it doesn't fall on this line right here, okay? So that means that if you were to graph these two lines, I don't know what the crap they look like, and I don't really care right now. But negative 3, 3, it would fall on the purple line about right here, but the other line, you know, it wouldn't, okay? But we need the intersection of those two lines. Now you'll see once we start graphing that usually the solutions come out very, very pretty, right? No decimals, no fractions. So what do we do when there is decimals and fractions? There's other strategies, and pretty much, at least in the past, they didn't require you to use specific methods. Will they on the next exam? I don't know. We'll see.